Good morning, students. Uh, Course is Analog and Digital Communication. This is another topic from Analog and Digital Communication. Generation of amplitude modulation and demodulation of amplitude modulation. The course instructor is Priyanka from ECE department. At the end of this session, you will be able to learn. You will be able to know the generation of amplitude modulation waves and know the examples for amplitude modulation, and you can know the demodulation techniques. And next, coming to amplitude modulation, amplitude modulation is divided into 4 different types: ordinary amplitude modulation, and DSB-SC and SSB-SC. SSB-SC, vestigial sideband modulation. Method for generation of these 4, we can use different types of generation methods. For amplitude modulation, we can use amplitude modulator, and for the method of reception, we can use analog detector. For DSP-SC, we can use method of balanced modulator, and for method of reception, we can use synchronous detector. For SSB-SC, we can use frequency discriminator and phase shifter. Similarly, for method of reception, we can use synchronous detector. Next, last, coming to vestigial sideband, we can use for generation of vestigial sideband, we can use balancer modulator plus vestigial filters. For method of reception of vestigial is synchronous detector plus vestigial filter. This is next for generation of amplitude modulation. For low level amplitude modulation, in generation of amplitude modulation, we are having 2 different types. First one is low level amplitude modulation, and second one is high level amplitude modulation. Now coming to low level amplitude modulation, we are using modulation is done at low power levels, and very small power is associated with carrier and modulating signal, and it is given to wide band power amplifier to boost the amplitude and modulate to desired output. Example for low level amplitude modulations are square law, diode modulation, and switching modulation. Similarly, for high level amplitude modulation, my modulation is done at high power levels. An example for high level amplitude modulation is collector modulation. Here in this slide, we are showing low level amplitude modulation and high level amplitude modulation, and examples of low level amplitude modulation and examples of high level modulation, and where the modulation is done. For low level amplitude modulation, the modulation is done at low power level. In high level amplitude modulation is done at high power level. And next slide, low level amplitude modulation. These are the block diagrams for low level amplitude modulation and high level amplitude modulation. In this low level amplitude modulation, we are giving baseband signal and RF carrier signal, RF carrier oscillator to low level amplitude modulation. Then the output of low level amplitude modulation is given to wide band power amplifier to antenna. For high level amplitude modulation, for similarly low level amplitude modulation, the output of low level amplitude modulation is given to wideband power amplifier, and the output of wideband power amplifier is given to high level amplitude modulator with respect of RF carrier oscillator and narrow band power amplifier. Then the output of high level amplifier modulator is given to antenna. And in this slide we are explaining about the low level amplitude modulation and high level amplitude modulation. Coming to next, demodulation of amplitude modulation. The demodulation is nothing but the opposition, the quite opposite process of modulation. In demodulation of amplitude modulation, we are giving modulated signal. This signal is represented as amplitude modulated signal. The output of amplitude modulated signal is given to demodulator or detector. Then we can get demodulated signal. In modulated signal, we are having both modulating signal and carrier signal as as known as modulated signal. This amplitude modulated signal is given to demodulator or detector, then we get demodulated signal. This is known as a baseband signal or a message signal. What we are sending from transmitter, say, is received through receiver. This is the process how modulated signal is converted into a demodulated signal. Next, the square law detector. The square law detector is example of low level amplitude modulation. In low level amplitude modulation, we are using square law detector. In square law detector is also known as a small signal operation square law detector. Here we are using a diodes in the circuit. This is the diode we are using in square law detector. This is the basic circuit of a square law detector. We are giving these are the characteristics of the baseband signal. Characteristics of the in square law detector in electronic signal processing, a square law detector is a device that produces an output proportional to the square of sum of inputs. This is a linear square law modulation circuit uses of non-linear current voltage. So, characteristics of diode, this method is suited a low voltage level. This method is suited only for low voltage levels. The square law detector circuit is used for demodulating modulated signal of small amplitude, that is below 1 volt, so that the operating region may be restricted to the non-linear portion of VI characteristics of device. VI characteristics of the device. This is the formula for the square law detector. What is next? What Here we can see V is equal to VDC plus M of t into cos omega C of t, that is DSB MA signal. Next, coming to linear diode of envelope detector. In linear diode or envelope detector is also the both linear diode or envelope detector, its output is proportional to the output of the linear diode or envelope detector proportional to the voltage of the input signal. Linear diode detector makes use of rectification property. It is used for rectification property of a diode. Such detectors are widely used in commercial radio receivers. This linear diode or envelope detectors are used in commercial purpose only we are using. It is the linear diode detector is the simplest and most basic form of amplitude modulation. Amplitude modulation signal detector and it detects the envelope of the amplitude signal. The amplitude diode detector can be built for just a diode and a few other components. Just a diode and few other components we are using in linear diode detector. It is very low cost circuit block within an overall receiver. This is a low cost receiver. And these are the waveforms of various points in our circuit. The first one is diode detector and coupling circuit. The second one is linear diode circuit. We are giving modulated selected signal, then we are getting the output, linear diode output. Next, advantages and disadvantages of amplitude modulation. We are having different types of advantages in amplitude modulation because the cost of amplitude modulation is very low and amplitude modulation signals are reflected by the earth from the ionosphere layer. Thus, they travel a long distance and cover a wider area, and required carrier frequency is also low. It requires a simple transmission and receiver. Then, then coming to disadvantages, it having amplitude modulation contains unwanted carrier components. Hence, it requires more transmission power. The transmission bandwidth is equal to twice the message bandwidth. And the second disadvantage of amplitude modulation is signals are highly susceptible to peripheral noises, and receiver of these signals find it difficult to distinguish between signals and noise. We cannot distinguish the message signal and noise at the receiver. Thus, the poor audio signal is of poor standards. Next, coming to application of amplitude modulation waves. Amplitude modulation wave increases the frequency of the message signal due to the presence of high frequency carrier signal. Hence, it is widely used in broadcasting. Where mostly amplitude modulations are used in broadcasting. Next one is application of amplitude. Second one is band radios. Amplitude modulation is used in portable two-way radio and band radio. For effective communication only, we are using amplitude waves. Amplitude modulation is used for audio broadcasting in long and medium wavebands, as well as for two-way radio communication via aircraft high frequency. These are the applications of amplitude modulation wave. And these are the short answer type questions we get from this topic. Amplitude modulation classified into how many types? In first one only we have to write for this answer. Write example of generation of amplitude modulation and demodulations. What are the examples of amplitude modulations and demodulation? For generation of amplitude modulation, we have to use uh, the first slide of the session is the answer